In this video, we're going to talk about Chapter 1, Section 5, which is the last section of Chapter 1, and we're going to be talking about proofs, which is a new idea for math that you guys probably don't understand yet, but that's what this video is for. So, a proof is when you want to say something is true. You probably know the word proof in everyday language. Like if you say, oh, I can, run, I don't know, let's say I can run a mile in 5 minutes, and no one knows that that's true just by you saying that. No one can say that it's true, but you can use things that you know are true to say that. You can say, okay, well, come out to the track and watch me run, and then everyone will believe. You'll prove to them that you actually can run a mile in 5 minutes. Um, so when we talk about that with math, we're going to look at this definition. There are a lot of definitions, but they generally say the same thing. This is the simplest one I could find from the Penguin Dictionary of Mathematics. It says that a proof is a chain of reasoning using rules of inference, ultimately based on a set of axioms that lead to a conclusion. So let's break that down. Proof is what we're trying to find. We're trying to find the definition of a proof. Now, chain of reasoning. So reasoning meaning using logic and ideas, using rules of inference. So that would be, let's say you're looking at a picture of a triangle and you have to do a proof on a triangle. Well, what are rules of inference in a triangle? There are these rules that you know are true about a triangle that you can use, and those are rules of inference. Ultimately based on a set of axioms. Now, axioms is probably the most important word in this definition, because what an axiom is, basically an axiom, accepted fact, okay? It's often called postulates. They're often called postulates. Postulates. Postulates, yep, there it is. And so an axiom is a fact that you can use in a proof because everyone knows it's true. Everyone knows it's true. And you have to say that it's true. So if we go back to the example with you running a 5-minute mile, not everyone knows that's true. So that's not an axiom. If you then go down there, run a 5-minute mile in front of everyone, and they time you, and it's 5 minutes on the dot, it becomes an axiom because everyone knows that it's true. But the steps to proving that it's an axiom, that's where a proof comes in math. So some common axioms that Euclid, the famous geometer, Greek geometer, came up with, said, well, one says that if you have two lines in space anywhere, sorry, 2 points in space anywhere, exactly one line can be drawn between both of them. It's through both of them, sorry. And he had some other axioms, like with parallel lines. If you have one line and a point outside of that line, there's always one other line that can be drawn through that line that will never touch the original line. Those are called parallel lines, but we'll get into that later, and those are denoted with these little arrows. But that's not what we're trying to get at now. What we're trying to say is, well, we use those axioms that we know about certain things in mathematics, and we want to prove other things that we want to know in mathematics. So say, I'm going to give this little, so we're going to use what we know to prove what we don't know. And that's pretty simple, right? So, first of all, what do we know about this triangle? Well, we know it has three sides. And if I were to give it to you on a test and say, and give you these three lines in each side, that means all the sides are equal. We'd know all the sides are equal. And from that, we'd also know that all the angles are equal. So there are some things we know as, those are axioms about the triangle. We know those are true. But then I'd ask you to prove something else. Like I'd say, prove, this is more advanced, but prove that these two angles add up to this angle, something like that, this exterior angle. You don't know that that's true yet until you prove it using these axioms that you do know. You do know that all these angles are equal. You do know that all these sides are equal. So use that to prove what I asked you to prove. And so I know it's a complicated idea, but I'm going to step through it with something a little closer to home, a little more familiar than mathematics language. So there are three types of proofs that you can use. You can use the two column style. You can use the paragraph style, or you can use a flowchart style. So I'm going to go a little bit more in depth of what each of those things are. So two column style looks something like this. Columns are the ones that go up and down, not rows like side by side. So I'd separate my two columns like that. And I have one column on this side, one column on this side. And let's say I'm trying to prove that it is good to eat bubblegum in class or chew bubblegum in class, okay? We don't know that it's true. We're trying to prove that bubblegum is good for you. So I'd write my proof up top. I want to prove that bubblegum is good. No one knows that yet. It's not true, but we're going to use axioms to prove it. So I kind of make like a T-chart here. On this side, on the right side, are the axioms, the reasons. And on this side are the statements. Okay, so the first statement would be bubblegum helps me focus. But how do we know that that's true? We have to use an axiom to say that that's true. So we'd write a 1 over here and say, let's say that something that everyone widely accepts as a fact is that chewing is good for the brain, okay? And so then we've used something, I know that everyone doesn't know this in real life, but use something on this side that everyone knows to prove what's on this side. And then you'd follow the sequential order of steps. You get to use everything that you've proven above you until you finally get to this desirable end that bubblegum is in fact good. Bubblegum is good because you've proved all these statements on this side with axioms on this side. So that's basically what a two-column style proof is. That's what I use in my math classes, and that's what I think is the easiest. But there's also a paragraph proof, which is really easy. Instead of just separating it into two columns, you just write bubble gum helps me focus because, and then you'd list what's on the axiom side. So a good way to think of this bubblegum, this two style proof is say what and because. So this is the statement over here. This is what you're trying to say, and this is why that's true. You're using axioms that are widely accepted in mathematics to prove why this over here is true. And then a flowchart really is just using these boxes. So you'd say here would be your what, and then connected to it would be your because. I don't recommend this style of proof. It's a little more difficult to, it's not as standardized, and it's a little more difficult to both do and grade. But that's the basic idea of a proof, and I'm going to go ahead and in the next video give you an example of a real-life geometric proof that we would be doing, you'd be doing in your classes and in your book and in your homeworks. So you can actually see what it looks like in practice. I know this video was probably very confusing, but pay attention in class and watch the next video and you should be able to understand.